Thank you for joining us. My name is Christian Holsing. I'm part of Intel, and I'm going to talk to you about confidential computing. And I have two colleagues with me that make my life totally easy, because if you have the deep technical kernel questions, they will answer that. So legal information, I'm just skipping that, so we're all happy with that. So I don't know how many of you have heard about the concept of confidential computing, as this is relatively new to the market. The major chip vendors are introducing this. Of course, ours is better for various reasons. Benny will explain you why. Just let me start with a little anecdote, maybe, to explain to you why it is important. So I assume most of you have heard about one of the big cloud service providers losing a root certificate a few weeks and months ago. The interesting thing for this is that if you think about it in the past, and if you listen to the keynotes this morning from the SUSE perspective, I think we all have really good technology at this point of securing data at rest with encryption on a hardware, on a disk level, on a software level. We all have a good understanding how we actually protect data in transit, encrypting the data flows. But one part that we don't have a good answer for until pretty recently is data in use. So what happens, and that was also the CSP problem ultimately, what happens if you have an inside attack, you have a virtual machine, and people get access to the memory of that virtual machine, and you have a root certificate or customer data or personal data in Germany stored in there. So there is an attack vector, and I'm not necessarily saying that it's only a concern of an attack vector. It's also compliance that I will talk about, regulations that we heard about in the keynote that actually come into play here, and that confidential computing could become a good answer for, to protect data on a different level and also enforce concepts. If you think about cloud operations of separations of duty ultimately, right? So it's not necessarily an additional burden, but it's also an opportunity for you as an organization, for users that host customer data, to really have an additional layer of protection here and security towards your own customers, internal customers or external customers, right? And security is something that is really a big challenge in a lot of projects. And we basically see security concerns. The slides will be published, so they're uploaded. I mean, you can happily take pictures if you want. I can step out of the way because I don't think I need to be on those, but the slides will be there. So the customer challenges, just to illustrate three of them, and there are potentially a lot more, is privacy and data concerns. AI Act, for example, that the EU just put in place, GDPR, all those were called out this morning. The whole question of data migration, right? I spoke about the CSP problem. So a lot of organizations move data to the cloud, but if you bring this over to AI, for example, right, and the SUSE announcement, the SUSE point earlier, you basically train an AI model on your company data, customer data, engineering data, and how far. And it's a rhetorical question, ultimately, that you need to find an answer to as an organization. But how far do you trust your cloud service provider on not looking into it? Because ultimately, they would have access to the data in memory or in the VM, right? So, and I'm not suggesting you shouldn't. It's just a question, really, of what measures do you want to bring in place? And then also the question of security. Can I rely that the machine is updated? So I will talk about this later. Is it the latest firmware? Is it the latest patch level? And we see a huge variety in these discussions of, for example, cloud service providers doing one reboot per year. And if you think about microkernel updates on the CPU, security patches, the question is, where is that? Is my environment secure, and do I have an independent attestation mechanism as a customer where I can actually check that my environment is on the latest level? So just a few thoughts about the regulations. So we see all of that not only in the AI space. I assume there are a lot of Europeans in the room, so GDPR is a big topic for us in the past. So various protections are coming in place. NIS2 is another one of these regulations in Europe that as an IT organization you will need to find an answer to. How can I comply with that? How can I prove that my data is actually protected to the latest level? And yeah, it helps me as an organization to keep myself compliant and secure. And from a historical point of view, very often the innovation and the privacy concerns, and I think we all have plenty of stories to talk about or to tell from the past. Like, usually you have a good idea, you want to bring a new technology into your data center, and then the chief security officer tells you, no, we can't do this. So at least that's my experience, that there is usually a lot of discussions back and forth, and people are checking on it. But from an Intel perspective, what we think we can really help here is getting compliance and innovation through confidential computing in a way that they actually not compete, but to some extent work together. If this picture is correct and the two trains are pulling the same level, we'll need to figure out. That's an ongoing discussion. But just from an idea, we believe that this picture illustrates things really pretty well. AI, I've spoken about. This is also something, if you listen to the various Intel keynotes, the various Intel speeches that we're having, you heard this from SUSE, confidential AI, due to the data that you put likely somewhere else, even in your own data center, even there it might have sensitivity, or in the public cloud. The whole additional level of how can I protect this data, how can I be compliant with my regulations, and how can I make sure that somebody else doesn't get access to my construction data, to my customer data. And we do believe that confidential computing, and that's one of the use cases where we also get a lot of traction, not only in the cloud but also on premise, is one of the driving forces here for confidential computing to really actually see adoption and gain traction in general use cases. So it's ultimately, and then I move into the more technical components. It's really the various regulations that we need to comply with, GDPR, and that has been a use case already for some while with earlier confidential computing technology, because that's not new from an Intel perspective in general. The whole question of where's my data located, in Europe especially, there are regulations in various countries that specific data can't leave your premises, and confidential computing, encryption of the workload during processing is actually giving you hopefully a little bit more flexibility here to comply and prove to regulations that this is it's an opportunity to move the workloads maybe a little bit further, and then also the question of can I securely move workloads over to the cloud. And I remember from previous experiences that I was working years ago with a banking service provider, and I remember the CIO being very, very vocal about moving to the cloud. He said, I'll be the first person to move to the cloud. and really drive that scale into my organization. But I'm regulated. In Germany, it's an organization called BaFin. And I need to own the keys to encrypt the data. Only if I can show that, I will be compliant to people. So, and it became a technology blocker for him, actually, to embrace cloud or consolidate workloads. And we had a discussion earlier today with a SUSE customer here at SUSECon, where also the use case of I need to separate workloads internally. I have multiple internal customers, and these internal customers run multiple workloads on the same physical machine. How can I make sure that Department A doesn't see data of Department B? And that's another aspect here of the value of confidential computing. And as I said in the beginning, it's actually not only Intel. So there is an open consortium that's forming around confidential computing. As I said, there are also other chip vendors that have embraced it, but we see more and more customers actually joining it, and more activity, and it's really becoming an industry standard, an industry initiative at this point over multiple chip vendors, over multiple software vendors that are actually embracing the standard. And from a Linux kernel perspective, you also see that there is standardization happening right now between the major chip vendors, and it's just becoming a generally available technology over time. We're not completely there yet, but there is drive, and from an upstreaming perspective, from the Intel side, really getting the code into the mainline and getting it accepted there, as well as downstreaming, getting basically confidential computing, the various frameworks embedded in Linux distributions like SUSE, so that from a customer perspective, A, it's easy for you to deploy and consume it, and B, it's also easy for you to get support. Because we're having some interesting debates in Intel from time to time where people are just saying, it's on GitHub, pull it down, compile it. I mean, most of you will be able to do this, no question. But really the question is, how can you keep up with it? How do you get support ultimately? And those work streams are happening at this point in time. So the compliance point, I think I stressed a lot, confidential AI. We're just seeing confidential collaboration opportunities right now that are starting to emerge, where customers are saying, I basically want a WhatsApp-like service, and I want this to run in a confidential computing environment just to have an additional layer of protection. So those things are happening under discussion, data sovereignty and data control. So we see a lot of that happening, cybersecurity. I mentioned that before in terms of, can I really put this additional layer of security in my environment, and how complicated does that become? So from a more technical perspective, what does confidential computing mean? So first of all, it puts certain workloads in a very broad way into an encrypted region in memory from a technical perspective. So, and it's handled on hardware, so dependent on how you do it. From an Intel perspective, there's the TPM chip who handles and generates the key. And basically, the CPU is then on the fly encrypting. And Benny, correct me if I'm completely off. Correct me.
It's not a TPM doing the thing, handling the keys, generating the key. It's a hardware component inside the CPU.
Okay.
Generating keys and managing the keys.
See, that's why I'm bringing experts. They can correct me on the fly. Now you threw me off. That's okay, I asked. No. So basically, as I said, on a very high level, you have virtualization that comes into play. So it's not working on bare metal as of now. So it's going through KVM on the Linux side. And basically, the memory of the separated workload is encrypted with a specific key handled in the CPU. so I'm learning. And that separates it from other VMs because the keys are unique, encrypted or not encrypted. So that's the very high level and simple view on it. But back to the example I started with the cloud service provider, that means I can log into the bare metal system and into the root OS, and without the key of the virtual machine, I'm not able to get access to the memory. So it's very, very high level explained. And the three aspects here are really isolation of workloads. So my second example I used before, really having multiple internal or external customers. If you're a service provider, and you have like different external customers running on the same machine, confidential computing gives you isolation. Here also for site attacks, potentially, or not potentially. Encryption and control. So as I said, memory is being encrypted through the CPU. And there is an aspect that Benny and I were discussing about in various customer engagements, which is verification. So what confidential computing also gives you is the ability to verify that the microcode is updated, the hardware is what you're expecting, and people haven't changed it. So that's the whole notion of attestation. And that's really part of the confidential computing story. So it's not only the encryption, but if you go back to the question of I'm running my workload in whatever your favorite cloud service provider is, I was joking about this earlier a little bit, you're trusting them today, what they are giving you. And attestation to some extent gives you a way to basically see if they are keeping up, if they are patching the environment, and deliver to you what they promised to do. Use cases and sectors where we see it quite a bit, and I'm talking about a few customer examples in a minute, but healthcare for very obvious reasons. So there is a Intel story that's been around for a while for a German health insurance company processing basically patients' data. So I think we all want that to be protected on the best possible level. Financial services is another one. Financial transactions, credit card transactions, retail, government, industrial and edge. I mean, even on the industrial and edge use cases, if you're metering power, if you're metering consumptions, different things, you might want this additional level here. And I don't know if I talk about availability in a chart. I think I don't. But right now, the use cases that we have are mostly server-centric, but they will also move to client CPUs over time. Right? And then, different usages, collaborative analytics, confidential AI we've spoken about, privacy preserving, if you remember the Fujitsu example this morning with ASFINAG, the Austrian highway system, which is basically capturing pictures of cars on the bridges. If you've ever driven through Austria, you might see the cameras on the bridges. And from a European perspective, your number plate is obviously protectable data. So that example also does the processing and the matching of your number plate against your name in a confidential enclave, so that the data is protected. And think about it, that it's like an API call ultimately from a software engineering perspective. So the code runs in a protected environment. You give it a number plate, you get a name back, but that's what you get. Data in, data out, pretty simple. And data software IP control, so we also spoke about that. So if you think about, and that's probably also good in edge use case, if you train a model that you want to deploy on edge nodes and you want an additional level of protection because the edge node might be on a power facility or something that is not guarded by people, there is another use case where customers are looking into it. So I was talking about ASFINAG. One of the use cases that we're highlighting from an Intel perspective is, for example, Bosch, autonomous driving. And it's pretty similar. I mean, from a European perspective, you have faces, you have number plates. All of this data is actually something that falls under GDPR ultimately. And moving the processing and the recognition into a secured environment and protecting privacy for people this way is an interesting use case that we see. And Novartis is another example, processing basically patients' data in a hospital and moving all of that into a secured environment. So these two examples are out there. I think we have use cases published on intel.com if you want to go deeper. So those are actually public references and use cases. And Fortanix is another one, which is a very different use case. That's basically key management. So just ensuring that you only release a key to decrypt data when you validated that the stack is actually compliant and there isn't any security problem in the underlying microcode or along the stack. So very different use case, but also a pretty interesting one, I guess. Okay. I think we've spoken about the AI case quite a bit. Maybe the interesting point to highlight here, and I don't know, Mark, if we're talking about this tomorrow in your session. So we're doing another upstreaming session tomorrow. But from an AI perspective, a lot of the AI workloads, if you talk about inference, basically the object recognition, for example, everything outside of training, that runs natively on, or could run natively on the CPU. So there is not necessarily a GPU required. You can run it on a GPU. Both options work. That's totally fine. But the point here from a confidential computing perspective is even the data that you would feed into the GPU outside of the VM remains encrypted. So because it's the data feeding also works from the CPU side, basically the whole use case end to end would work here for GPU and for CPU inference and training. So just wanted to highlight that part. If you have questions, you're looking a little like you want to raise a question. So as I said, I bring the knowledgeable people for the hard question. I can just advertise your session for tomorrow again, so you can ask him the hard question again.
Maybe I'll find out the answer to this one.
Yeah, and then we can just mention it.
We'll just end it. Yes.
No, that's fine. I mean, as I said earlier, right, this is also work in progress, and as Mark said, we're on this, we're evolving it, but we're also here to hear feedback and understand what do customers need and what are the shortcomings. And Benny, who also helped, he's in Germany on our enablement team for this technology. So we're very, very curious to have these discussions, and we encourage these hard questions, right? Because it only makes the solution better for all of us, I think. So, see, I was reading you.
It's not too hard, I think.
No, it wasn't hard. It was a cheap steal. Okay, cool. So I mentioned that before. So the confidential computing requires some sort of hypervisor or some sort of, well, I think SGX you can probably also, in a very loose sense, define as a hypervisor approach that you move part of the code into the security enclave, and I'm talking about the two different options in a second. Key management, Benny talked about, so that's completely transparent. And when you deploy it and you enable a confidential VM, for example, on KVM, you wouldn't even notice it much. So you say it's a confidential VM and the rest is handled by the hardware, pretty much. There's a little bit more of setup, and we're working with SUSE through it to just make it as seamless as possible, but in theory, it's super simple. and not much additional work. And the attestation service I spoke about before, and I cover that a little later. So these are the main components. And from an SGX perspective, secure guard extensions. So Intel is all about 3-letter acronyms, and they make it really hard for employees. We use them 4 or 5 times, the same one. So it's context sensitive. So SGX has been around for quite some time, and SGX basically is a change to the code. So when you write an application, there are various frameworks in Python and JavaScript. I think even Java, right? So that you can basically take a function, and this function is then being moved into security enclave and is being executed there. So that was my API example earlier. For example, the healthcare insurance was using SGX. Not the one on the slides here, a different one. So the processing of the data is basically sent into a secure enclave. But really the challenge is that you have to change your application. Even if you put a wrapper around it, there is an application change, or you need to factor it in when you start building the application. At that point, it's relatively simple, so everything cloud native or standard application, you could just build it in. Compatibility is there for a broad stack. So SUSE has this on SLAS since a while. There are various opportunities outside of our existing ones in the CPU that can be integrated, and a variety of attestation services. We talk about that in a second. And there is also opportunities outside of Linux should anybody dare to want to use that for whatever reason. The newer technology that we have enabled, and it's in broad availability since Emerald Rapids, that's Xeon 5, is TDX, Trusted Domain Extension. And the difference to SGX is basically that you can move a full VM completely into the security enclave. So that's a very, very big difference here, that in SGX, you were just using or moving a certain function into a confidential enclave, and TDX makes it very simple. You're just spinning up a new VM, you make it a confidential VM, and the system then encrypts everything that's running inside of the VM, and you don't need to change data. So obviously, one of the interesting use cases for us is to look into SAP workloads at some point. You know, just moving an SAP HANA completely into an encrypted VM. We're not there yet, in case you've heard the talk from Gerion on KVM validation. So we're working on that right now, and at least I remember the acronyms of our CPUs in contrast to the SUSE people yesterday, but I think they were just a little nervous about it. You need a compatible guest OS. So you won't be able to just use /12 or something. I mean, I think there are still people that really love that and using it. It needs to be SP5 at a bare minimum, 15 SP5 from a SUSE perspective to even run inside of the VM. And the whole confidential compute, I cover this later, is also available in the cloud service providers. So there is also a specific requirement. And you know, if you just connect the dots, and I have a slide later on that, if you just connect the dots, there is a lot of encryption and decryption of memory regions and pages happening in the back, and the kernel just needs to know that he needs to trigger this function. So that's basically, on a very high level, the explanation of it. And then the question of the compatible hypervisors, and dare me, I still haven't updated it to SLAS. So SLAS 15 SP6 also supports TDX now. We're in active discussion. There is a tech preview. I have it on the later charts. So before Matthias Eckermann kills me on it for all the right reasons. So I might just need to run away from him. But so SUSE needs to be listed there. I fixed this for the handout. SP6 is basically compatible as well for TDX. So if you want to spin it up, you can definitely use that. And from the attestation side as well, there are various services on the attestation that you can use. Intel provides one that we talk about in a minute. The cloud service providers provide an attestation service. Then it comes back to the question of which service do you want to trust as an organization and which independent do I want? And that's an interesting question. You know, am I trusting the cloud service provider that I want to validate? Do I trust the hardware vendor? I mean, ultimately, you need to trust someone. Might also be SUSE you want to trust. You need to start somewhere to run the attestation, but there are multiple options. And as I said on the previous slide, it's a consortium, so there are a lot of players that drive standardization into this topic, right? So different view, trust boundaries. So, but I think this should be relatively obvious. So I basically have, without confidential computing, no trust in my application or data. So as a IT operator, I just trust that whatever I get isn't tampered with. And when we then start to add TDX into the picture, as I said before, the whole guest VM, including the whole operating system, all applications running on there, whatever it is, are encrypted. And for SGX, it's basically the app or the part of the app that moves the processing and the confidential data into the security enclave. So from an overview perspective, the two technologies side by side. It really depends on your use case, but from a deployment and setup perspective, really the easiest way without a lot of changes is to start leveraging TDX, building up a VM, putting the workload there, and the example on separation that I mentioned, the discussion we had earlier was also something in this direction where the customer was saying, I have multiple Kubernetes nodes running next to each other. So I'm could deploy a Kubernetes node inside of dedicated VM and then have multiple nodes on one physical hardware running. And I think we got some interesting discussions earlier on. I don't know if you've noticed that we launched 2 weeks ago our Sapphire Rapids line, Xeon 6, that has 288 cores on one socket. So you get a few Kubernetes nodes on such a machine. And confidential computing separation in this context is something that definitely makes sense in a lot of use cases, right? And from an SGX perspective, it could be a cloud native app that you're using or some specific processing that you want to separate and put into the enclave. The next level of discussion that we're having, and I don't have a slide on it, I just mentioned it verbally, that if you think TDX one step forward, then you're also coming to confidential containers. So there is work going on right now, and I think it's been upstream from our side, not accepted yet, we're working on it, that basically we're bringing the same concept of a micro VM up to Kubernetes, and you could say on a Kubernetes cluster without isolating the whole cluster, defining a set of containers that run in a micro VM and are then encrypted just by themselves and run in their own context. So even that work is going on. And as Mark said, the standards are also evolving. So encryption of the data, TDX Connect is happening. If you think about it from a technical perspective, the whole question of live migration becomes pretty interesting. So that's something else that the teams are looking at right now, how to make that work, because ultimately you will need to hand over keys. And how do you do that securely? So interesting challenges. But also these topics are actually really being looked at this point, and the industry is working on that and is implementing that. Okay, availability. So as I mentioned, sure. Who wants to go first? Yeah. Yeah, I think, I mean, it's an interesting question on VMware tools, right? The question is I think it's probably a risk mitigation question if you need that from a business perspective for whatever reason, or if you're saying, for the secure workloads. I mean, you're right on your comment. I mean, it's drilling a hole and a side channel into the whole environment for communication. The question is, is that something from a IT organization perspective where you're saying there's a risk and I'm just looking at these channels, or is that something that we should address or VMware should start to address, and from a software perspective, just at least alert the user and saying, hey, you're drilling a hole in here and you're just invalidating the whole confidential VM idea by putting a side channel in. So talking about Google, nice segue, Mark. So the initial availability of confidential compute was in public cloud, which was one of the prominent use cases. So I mentioned it before. For on-premise deployments, it's coming with Xeon 5 Emerald Rapids in broad market availability. But there is a preview on Microsoft. Mark mentioned Google. Alibaba Cloud has a deployment, and we're just working with IBM Cloud as we speak to get TDX and confidential computing enabled in the IBM Cloud. So a lot of discussions. The questions why AWS isn't listed there, we can discuss at the booth. Okay, confidential architecture. So that's basically from an attestation perspective. So the big difference down here is the attestation for SGX goes down to the application. And I'm just speeding up. We're running a little bit out of time. We have 5 minutes left or 4 minutes left. So attestation in general, just from a very high level concept, think about it that the system collects in SGX, in a secured enclave, data about the CPU. The hardware is hashing that and uploads it to an attestation service, which then, like Benny was saying, in a two-key environment, or the HTTPS TLS implementation that we're all using, just gives you a response with a key that then you're validating again against an independent party. And part of the message, what's being collected, is firmware versions and all these kind of things. And from an Intel Trust Authority perspective, that's one service that Intel has launched. There is a set of checks that you can implement on the service. And there are various discussions with SUSE ongoing right now to see how can we enhance that, and how can we basically use tools like SUSE Manager to basically take actions on it. Now, if I'm going back to my previous HANA life, I don't want to necessarily shut down a HANA database just because the attestation failed. But what you could do actually in this case is have a failover initiated and isolate that node, right? Or at a bare minimum, start alerting an administrator and saying, you need to look into this. The firmware is not what is expected to be. And there is another interesting use case as well, that you can extend the trust boundaries also to the kernel and OpenSSL and other libraries. So that's not there yet. It's an idea that we're discussing and working on, but the means are there, and we can potentially standardize that and bring that forward. But that really helps you that you can attest and on an ongoing basis or during boot really see that the environment, especially in the cloud, is what you're expecting it to be on a hardware level. And then if the attestation fails, you can start to take actions on it. So That is also something that that we're working on right now. So overview, I skipped that. You can read through that. The attestation flow is, for example, this is for a key release use case. Benny mentioned that with the third-party key release, for example. So the use case is that the machine comes up, it requests the attestation service for a token. The token then gets sent back to a third party, for example, the key service that manages your decryption key. And only if the token is validated, so there is a call here that's going back to the attestation service, and like in TLS, basically it validates the data here that the system is what it's expected to be. It's giving the key back to decrypt. So I think the Intel Innovation keynote is still on YouTube. There is an example from Thales that our CTO Greg is explaining there. So it's maybe interesting to take a look at that. And there is also a SUSE video in it, I think, if I remember correctly. This is really the more technical flow of it. It's really from the documentation. But really from a flowchart perspective, and Benny and I had a few interesting discussions of this component down here, the relying party and the validation of the key. That's really, really important. I mean, it's like when you do HTTPS and you get encrypted data and a part of the key, and you start you stop checking it right there. You don't have an end-to-end flow, so you want to validate the encryption key. That's what the browser does in the backend anyway. And that is really part of the whole flow, having the independent validation and check of the key. And there are two different patterns here from the documentation: the passport attestation and the background attestation. So you could also run it as a cron job or as a systemd job, for example, that on an ongoing basis just sends the token back. The question is, how often do you want and need that? As a techie, you probably want it every second, but that might be a little too much. So that's that part. Here's a little bit of what I mentioned before from a TDX perspective and why there's upstreaming work and kernel changes happening. So we heard a lot of the hypervisor and the changes of triggering encryption and decryption of the memory, and also the guests, just really as a reference of why this work is happening. General overview from an Intel perspective, where we are. So we're in upstreaming process of the whole TDX patches with the kernel community. I think that should be done relatively soon, from what I heard last. So, we see, as I said, cloud service providers that embrace it, different hypervisor versions. So this is really more the technical view of where things start and what kernels are required, and so on for your reference. From an enablement perspective, from the SUSE side, and I think that's why we're all here. So /15 SP6 has a module that's going to be available in the next couple of days. I don't think it has been officially enabled yet. I think that was at least the state last week, where you can basically enable the module, and you would get the patched QEMU, KVM versions, kernel versions, and just run the zipper up, and it would basically update, enable the whole stack, the whole confidential computing stack on the host. In the guest, it's just standard SP5 or SP6. So that's not a big problem. And from the CSP perspective, SUSE is maintaining specific images on GCP, on Azure, and they are enabled, and the team is actually building the required patches into those images out of the box, so you can go and start that. So Guest is there, it's fully supported. Host is in the tech preview state. So if you want to work with us and push that forward, find us or find SUSE. We're very, very closely collaborating on it, and we're just discussing a couple of production usages right now where we really want to bring that to market. Attestation is something that will come soon, and it's not part of the preview. In the guest, it shouldn't be a problem. On the host, I would test that, but it should work. I don't see why it should not work. The more interesting question is TDX has a hardware component on the microcode, and we were just discussing last week how we handle one of the cloud service providers mentioned before is trying to reboot their machine once a year. So if you start patching the firmware of the CPU, in the middle, that's going to be an interesting challenge, and we need to find a operational process for that. Okay, so I'm wrapping up. People are coming in, so I want to give people the chance to set up. So here are two different views from the SUSE perspective. We're at SP6 right now. SP7, the planning is ongoing. That was guest, that was host. It's in the handout, so you will see the reference from the SUSE slides. Okay, so that brings me to the end. Sorry for running over, and thank you for my two technical experts to jumping in and supporting this. Find us at the booth if you have further questions, please. We're around today and tomorrow.